All right, let's talk about methods of factoring. Some of this you'll be familiar with, and some of this will be new. The first one. This is the method I'd like you to start with every single time. You look for something called a common factor. Is there anything that goes into these terms? The answer is yes. What's common to 10 and 5? 5 is. What's common to x squared and x? 5x. So 5x is the common factor. What do you multiply 5x by to get 10x squared? 2x. What do you multiply 5x by to get negative 5x? Negative 1. The place most people go wrong, if they're going to go wrong, is right here. They might think the 1 doesn't matter. If you have 2 terms in the beginning, make sure you have 2 terms in the bracket. You can check that. 10x squared minus 5x. Then you need to solve it. What would make this equal 0? And what would make this equal 0? I'm getting 0 for the first one and a half for the second one. What you want to look for in questions like these is you want to look for all terms having something in common. It works for any number of terms, and it should be the very first method you try every single time. All right, this one you should know how to do. It's known as the difference of two squares. When you have the difference of two squares, just like we were doing before with our factoring, what squares to give you x squared? What squares to give you 9? And then one answer will be positive and the other answer will be negative. Why does that work? If one answer is negative and the other positive, when we check it, we end up with no x's in the middle. Now to solve it, what would make that one equal 0 and what would make that one equal 0? I think you're familiar with this one. Look for squares and negative signs when you do this one. And this works for 2 terms. So difference of squares, 2 terms that are both squares, negative sign between them. What squares to give you x squared? What squares to give you 9? One answer positive, the other negative. This will be new. This is known as the difference of cubes. When you factor the difference of cubes, you start by saying what cubes to give you each term. So instead of what squares to give you those terms, what cubes to give you them. So x cubed gives me x cubed. Negative 2 cubed gives me negative 8. Another way to think of it, take the cube root of each term. Once you've done that, there's a rule for getting the bracket. This is simply a rule that you memorize. Eventually I'll explain where it came from, but not today. Take this term and square it. Take this term and square it. Then multiply those two together and change the sign. So let's look at this. We'll do it again. Where did this come from? We said the cube root of x cubed is x. The cube root of negative 8 is negative 2. We squared the first term. We squared the second term. We multiplied these two together, changed the sign, and that's where the 2x comes from. Now the interesting thing about cubes, works for cubes in a negative sign with 2 terms. It also works for the sum of cubes. So anytime you have 2 terms, either the sum or difference of cubes, the method is the same. So we'll see how good you are. See if you understood what we did up here, because you should be able to factor this yourself now. So we start by taking the cube root. Cube root of x cubed is x. Cube root of 27 is 3. And it would be a positive 3. Then the rule is square the first term. And by term, I'm meaning the first term in that bracket. Square the last term. Multiply those two together and change the sign. There it is. I hope you got that on your own. Solving that, we get x equals -3. Now we have to talk about this. It completely depends if I'm asking you to solve this for x as a member of the reals, or if x is a member of the complex. If x is a member of the reals, we would stop at x equals -3, because this always gives us imaginary roots. The only time you would continue on is if instead of saying x is the member of the reals, we said x is the member of the complex, and then you're going to have to solve the last one. And I'll tell you, it always gives you imaginary roots, so you're going to need to use the quadratic formula. Now, if anyone's looking at this saying, I don't believe you, I don't think this actually works, we could check it. We could take x minus 2, multiply it by x squared plus 2x plus 4, and just verify that it works. We're really not sure where the formula came from. I will give an explanation in a few days' time, but we might want to verify just to make sure everything is good here. So x squared times x is x cubed. X times 2x is 2x squared. X times 4 is 4x. X squared times -2 is -2x squared. -2 times 2x is -4x. -2 times 4 is -8. Okay, that gives us x cubed. Those two eliminate each other. Those two eliminate each other. And the only other term left is -8. So it works. You're just going to have to memorize it for the moment. And it works anytime you have cubes and a positive or negative sign. And always two terms. So the rule again, take the cube roots. And after you've taken the cube roots, square the first term, square the last term, multiply them together, and change the sign. And doesn't this look like fun? This is known as trinomial factoring, tri meaning 3. So when you see 3 terms, also known as quadratic form. So this is an equation in quadratic form. So we're factoring just like we did our quadratics. What squares to give us x to the 4th? X squared and x squared. What multiplies to give us 9? I'm going to use 9 and 1. The reason I'm not breaking the 9 down is because the 10 is quite large. I've got 9x squared and 1x squared. Is there any way to get -10x squared out of that? I think there is. If they were both negative, there's our -10x squared. So 3 terms factors into that. Beautiful. So this is really a quadratic that's just a little bit bigger than normal. Instead of x squared and x, it's x to the 4th and x squared. Now, this is our opportunity to see if you're really good at factoring. 2 terms, both squares, minus sign. This is difference of squares, so keep going. What squares to give us x squared? What squares to give us 9? One term negative, the other positive. Same thing happening here. What squares to give us x squared? What squares to give us 1? One term negative, the other term positive. 4 answers for that one. And if you think of what we learned in graphing, when the degree is 4, how many roots are we expecting? 1, 2, 3, 4. So that'll give you a good idea when to stop. The other thing that tells you when to stop, when you get down to x to the power 1, or you get a quadratic that we just can't factor. So as long as we're dealing in the reals, if you get a quadratic that doesn't factor, you stop. So what do we look for this method, the trinomial factoring in quadratic form? You look for 3 terms. That's where our trinomial factoring comes from. And quadratic form, we mean the first term has a variable of x to the 4th. And that should be the square of the second term. So it works for x to the power 1 and x squared. It would work for x cubed. And the square of that one, this is not quite as obvious, is x to the 6th. So any terms that look like that, That will be trinomial factoring or quadratic form. One more for you. This method is known as grouping. What you look for is a common factor to those two terms. I think x squared goes into both of them. So x squared is common to the first bracket. So we're going to pull it out. What do you multiply x squared by to get 3x cubed? What do you multiply x squared by to get x squared? Let's just verify that that worked. 3x squared, 3x. Okay, we're then going to have to group this one, and if we group it, it must end up with 3x plus 1 as your second bracket from here as well. So these two have to be the same. If they're not the same, this method does not work. So let's see. Common to these two, the only thing I see is a minus sign. If we haul that out, do we get what we started with? Minus 3x minus 1, beautiful. So when these two brackets are the same, we can keep going. If we tried to haul something out and didn't get the same bracket, then this method would not work. Now, what do you see that's common? We have a 3x plus 1 that is now common. So we're going to put the 3x plus 1 out front. And what is it multiplied by? It's multiplied by x squared minus 1. Now this is the part that often gets people, so we'll just look at it a different way. Imagine you had ax squared minus a. You would say you've got a common factor of a, you'd pull it out, and you'd say it's multiplied by x squared minus 1. We're doing the exact same thing up here. The only difference is instead of a, I have 3x plus 1. So that's common, comes out front, multiplied by x squared minus 1. Let's just look at that nicely. We pulled out the common factor. After we pulled out the common factors, we had this in common. So we factor that, multiplied by x squared minus 1. Does it matter that it's the reverse order here? No. When you multiply things together, the order does not matter. And again, keep going until all your x's are to the exponent 1. Or you cannot factor any further because it doesn't factor. Two terms, minus sign, squares. That'll be difference of squares. What squares to give you x squared? What squares to give you 1? One term negative, the other positive. Now you can tell me all your roots. 1, negative 1, negative 1/3. What you look for in this method, terms that are in the same ratio. So what we mean by the same ratio. Let's look at this term divided by that term. If you were to take 3x cubed divided by x squared, what would you end up with? We can take an x squared out of here and an x squared out of here. And we're really just comparing the numbers. So my numbers, 3 and 1. Then we compare these two. Negative 3x minus 1. We can get rid of the negative sign. Ooh, there's our 3x again. Ratio 3 to 1. When the terms are in the same ratio, this method will work. Meaning when you haul out the common factor, there'll be a term in brackets that's common. There must be an even number of terms if you do that. So if we had 5 terms, forget it. So this will work for 4, 6, 8, or 10. All right, let's take some examples and put this all together. I have a summary of all the methods we've just done, and I'll show you what I'd like you to do. The very first thing you do, check for a common factor. I've got a no on that one. So no common factors. Keep going. 2 terms? Nope. 3 terms? Yes. So let's stop here. So we're going to look at quadratic form. Is it in quadratic form? That's the square of that? Yes. So we're going to keep going. So what squares to give you x to the 4th? What multiplies to give you 4? And did that give us the middle term of minus 5x squared? Yes. So we're in business. Continue on until this is the exponent 1, or you simply cannot factor because it's not a quadratic that factors. I now have two terms, minus sign squares, so that's the difference of squares. So now we're going to use that formula. What squares to give us x squared? What squares to give us 4? Minus positive. Do the same thing here. And there are the 4 answers. We were expecting 4 answers because the degree is 4. Let's try another one. Always start with the top. Do we have any common factors? Is there anything that goes into all of those? I think the answer is yes. Everyone's got an x. In fact, everyone's got at least 2. So we're going to take the x squared out. That's our common factor. Double check. X to the 5th minus x4 minus 16x cubed plus 16x squared. All right, we've done the common factor. We can't do 2 or 3, even or more. We're going to try grouping. Are these in the same ratio? I've got -1. -16 over 16 is also -1. So they're in the same ratio. We're going to group them. Haul out what's common and factor it. So common to these two is x squared multiplied by x minus 1. Common to these two is 16 multiplied by x minus 1. If you're in doubt, double check. X cubed minus x squared minus 16x plus 16. So we kept the x squared out front, and then we kept going. Now we have an x minus 1 that's common. So we'll pull that out, and what's left in the bracket is the x squared and the minus 16. All right, continue on. I see 2 terms, squares, negative sign. That would be difference of squares, and we'll factor that. Now, a couple of things to look for when you write math and it looks good, which is what I'm going to expect of you. We want this line to equal the one before it. This line equals the one before it. So you don't leave things out. We don't say, we dealt with the x squared. We're just not going to write it down. We're not going to leave the equals 0 out. We're going to make sure every line matches the one above. That is how you write math, so it's clear and easy to understand. Lined up, not scrawled all over the place, and this is what I'm expecting when you hand in any work to me marked. Keep going. What are the answers? What squares to give you 0 for that one? I think the answer is 0. 1, 4, -4. Now, I'm writing 0 down twice. You don't have to. If you're actually just asked to factor this, we'd stop. If you're actually asked to solve it for x as the member of the reals, we'd keep going. And the reason I'm writing 0 twice is for when we graph it. So if we were graphing this, 2 x-intercepts at 0, 1 at 1, 1 at 4, 1 at -4. Degree is 5. The reason I'm writing this down twice so as I remember the bounce. You can choose to just write the x down once if you're asked to solve, and if you're just asked to factor, you'd stop here. Okay, x cubed plus 1. Are there any common factors? No. 2 terms. We better stop here. They don't look like squares to me. I think these are cubes. I think we're in sum of cubes. Ooh, can we remember how to do this? Cube root of x cubed. Cube root of 1. Positive 1. Square the first term. Square the last term. Multiply the terms together and change the sign. Let's see how we did. It's the sum of cubes. Beautiful, we got that right. Now where you go from here depends on whether I asked you for x as a member of the reals or x as a member of complex. Just for fun, because we haven't done this, let's do it as if it was a complex. So this is a quadratic. I will tell you that anytime you do sum or difference of cubes, this will not factor, and you must use the quadratic formula. So let's just do this for fun. B is 2, A is 4, and C is 1. All right, what does that give us? I'm getting 4 minus 16, which is negative 12. As predicted, it's going to give you imaginary roots. So remember what to do with the square root of a negative 1. We make that into I. Now, if you'd like to go further, this is worth your while. Square root of 12. That's the root of 4 times the root of 3. And we know the root of 4. So we can write the root of 12 as 2 root 3. So where did this come from? Anytime you write down a square root, you're looking for perfect squares. So I'd look for numbers like 4, 9, 16, 25, see if I can break down any of the roots. Now you can take this one step further. 2 goes in here once, 2 goes in here once, and 2 goes in here 4 times. So a better answer is this. Negative 1/2 comes from here. 1 plus or minus I root 3 to the over 4. And we're expecting 3 answers if I'm asking for complex. If we asked for real, you'd know you'd have 1 real answer and that would give you 2 imaginaries. All right, let's try another. Always start here. Do we have any common factors? Anything that goes into 27 and 3? I believe the answer is yes. So take the 3 out. Multiply by 9x squared minus 1. 2 terms. Got a minus sign and they're both squares, so that would be difference of squares. What multiplies to give you 9x squared? What multiplies to give you 1? The terms are negative and positive. Answers for this. What would make that equal 0? What would make that equal 0? And why aren't we doing anything with this? You cannot make 3 equal 0. That's why there's no answer coming from this. So our answers, 1/3, negative 1/3. 2 answers. We're looking good. Your job today, lesson number 4, 1 to 8. Practice, practice, practice. Get good at this. You're going to see a lot of this in your future. If you have questions, just let me know.